Hello and welcome to Grade 7 Science Intro to Geologic Dating. During today's lesson, there is something I'd like to invite you to think about. In Earth's long history, how do scientists know when particular events took place or the order in which they occurred? If no one was around to record these events, why do scientists think that the Earth was created so long ago, or that life started out as only a very few single-celled organisms? Or that dinosaurs came before mammoths and not the other way around? Let's take a look at our learning targets for today. We actually have two of them. Our first target for today is that students will be able to describe two different methods that scientists used to put together the sequence of Earth's long history. And our second target is that students will know the limitations and some complexities to these methods as we go through them.
Before we get any further into the lesson, let's take a look at the vocabulary that we're going to need for today. I'll start at the top of the list, and we'll work our way down towards the bottom of the list. We'll begin with relative dating. It might sound familiar to some of you because we discussed it briefly when we were in the evolution unit. We'll follow that up with superposition, strata, what constitutes a geologic column. We'll also talk about sills, or as some people refer to them as geologic dikes. We'll discuss unconformities, and then we'll get into absolute dating. We'll finish up with radiometric dating and radioactive decay.
At this point, you should open up the Intro to Geologic Dating worksheet that you see in front of you. You should be able to find it in the Google Classroom provided as an assignment from your teacher. So please locate that document in the next few minutes. Pause the video now if you need time to open up the worksheet.
Now everyone, I want you to think way back to when we studied an idea called evolution. At that point, we briefly discussed some ways that scientists used to put the fossil record together in the correct order. What were those ways? If you came up with relative dating and absolute dating, you have a pretty good memory. Go ahead and pause the video while you put those two down in the first two blanks at the top of the packet, just before question number 1. Okay, pause the video now and fill in those blanks. Welcome back, everyone. As we go along here, you'll see several slides that follow along with your packet and provide you with some notes that you will want to fill in on that same packet. You may notice that I put all of these notes in this violent pink font to make sure that it stands out for you and as a signal that you should be taking notes of this. You may need to pause the video at points so that you can write in your notes. And occasionally you may want to run the video for a little bit and just listen. Then go back and play the video again while you write your notes while pausing it at certain points. So you might go through this start, pause, write down, start, pause, write down, that type of cycle. You might do that a few times with this lesson, and that's perfectly fine. Okay, let's chat about relative dating for a while. When we introduced it in the evolution unit, we never really got to the reason why it works and what it does and any of the complications or limitations to it. Today we'll be getting into more of those details. Relative dating doesn't have to be geological necessarily. It just means that you're comparing the ages of things when you don't actually know any of their ages. You might ask how this is possible. That's a great question. I'll try to illustrate it with an example.
Alright, now take a look at these guys. I've placed them in no particular order. See if you can put them in order from youngest to oldest. I'll wait a few seconds while you sort them out. Okay, if you said D, B, A, then C, then you put them in the same order as a whole lot of other people. Notice that we were all able to do this, and none of us ever really knew any of their ages. This is relatively dating, and we'll be doing it with rocks next.
Look at these rocks. Do you think it will be easy or that we'll have as much agreement about the order of which is the youngest and which is the oldest? Rocks are much harder to date by looking at them. So you remember how geologists generally rank rocks in the earth by their age? You might remember that they use something called the principle of superposition. that basically states that rocks that are buried deeper are generally older than rocks that are buried more shallow. This only applies, however, in undisturbed areas. Now, an important limitation to this is that the area can't be disturbed. So what do we mean by disturbed? Well, when scientists see an area where the rock strata or the layers have not been disturbed, and all the layers are present, they call it a geologic column. Scientists can also create a geologic column on their own just by looking at different areas that have been disturbed and rearranging those layers in order from oldest to youngest so that they appear in a way that is no longer disturbed. Now your turn. Take a look at question number 3. Pause the video now and give it a shot. Restart it when you're done, but pause it now and write down your answers. Welcome back, everyone. Superposition is simple to do, but as with most simple things, it does have its limitations. Among them, you never really know the ages of the rocks. You've only made comparisons of their ages. It only works this easy when the area hasn't been disturbed as well.
You may be asking yourself, what types of things would disturb the strata of stone? Well, probably some of the things you'd expect, but maybe one or two that you wouldn't. Things like earthquakes. Also, the movement of tectonic plates. Those can force some of the younger rock underneath the older rock, or even uplift older rock. Also, magma. Magma might get pushed up from the mantle and then cool down at the same level as older rock. And finally, erosion. Erosion can completely erase or misplace rocks in the column.
Take a look at these different disturbances. What could have caused them? Well, you might have come up with a short list if it included earthquakes, tectonic plate movement, or other internal forces of the earth. You would have matched with us.
All of those seem relatively straightforward, but a more complicated disturbance is when magma gets pushed up and cools below the surface.
Let's look at this situation a little closer. This is called a dike, or a sill of igneous rock. It is made from magma that got pushed up into the higher layers and then it cooled. That's why it's considered younger than the strata surrounding it. Along the edges of igneous dikes, the heat and pressure from the magma getting pushed up often turns the sedimentary rock into a thin layer of metamorphic rock. If you'll remember, metamorphic rock is always created from extreme heat and pressure.
One last disturbance that we'll take a look at is when a layer of the strata is completely missing. And this is because of erosion or just a lack of sediments being deposited. When this happens, we call it an unconformity. It represents a missing gap in the rock sequence. And for many geologists, it also means missing time, since we don't have any record of what took place at that point.
This is one of those geological mysteries here at the Grand Canyon. Here we have rock that's 1.7 billion years old, 1.7, 1.7, boom, 525 million years old. That line right there represents a billion years of Earth history that was just erased from this part of the Grand Canyon. And the gap between those two rock layers is what we call the Great Unconformity.
Right, that's enough about relative dating and its complications and limitations. Now let's discuss the other way that scientists know the age and the timeline of Earth's long history. Absolute dating. Scientists also have a way of determining the actual age of a rock or fossil. That's absolute dating. They do this by looking at the properties of atoms contained in the rock or fossils. Generally, this is referred to as radiometric dating, a type of absolute dating. An example of this is when rocks are created or when animals are alive, they all have a few atoms that are radioactive. This means that the atoms will at some point shoot off parts or energy into its surroundings. After they do this, they are no longer radioactive.
This is called radioactive decay. When there are a lot of these atoms, like in a nuclear reaction, this can be actually very harmful. But in normal rocks and other things, there are just too few to be unhealthy. So it's perfectly normal.
As we move on to question 10 in your packet, we should know that scientists measure the amounts of atoms that are both radioactive and non-radioactive in a rock or fossil. A rock that has more radioactive atoms will be younger, and conversely, a rock that has less radioactive atoms will be older.
This probably sounds like we're comparing ages again, similar to what we were doing in relative dating. But that's not really what's going on. It's because scientists know how fast atoms radioactively decay. They can tell from that the age of something by measuring just the amount of radioactive atoms in that particular sample.
To summarize, we're going to take 5 minutes to write a summary of the 2 ways scientists use to determine the age of a rock. We want to write an argument the same way we do in English class, starting with a topic sentence that introduces the point or the topic. Since there are 2 ways that scientists use, we'll write 2 different supporting sentences and elaborate each separately with an example. And while we're writing, we'll make sure to use some of the vocabulary that we've been using in this lesson. So go ahead and pause the video here and take some time to write a good summary. Go ahead and pause it now.
Welcome back. How did it go? Did you write complete sentences, or did you just use keywords? Did you discuss how superposition is used to relatively date rocks in their strata? Did you discuss how radiometric dating is used to find their actual age? Did you elaborate on both methods?
If you missed any of these things, then my suggestion is that you pause the video and go back and try it again. Make sure that you're using complete sentences. Make sure that you're discussing how superposition is used to relatively date rocks. Talk about how radiometric dating is the method that scientists use to find the actual age of rocks, and make sure you're elaborating on each. Go ahead and pause the video now if necessary.
When we come back next class, we'll be doing a couple of different things. We'll be reviewing and practicing the material up to this point. You're going to need to bring your laptop to class, and much of the practice that we'll be doing will be done online. I hope you enjoy it. See you then.